Very nice to see you. So this talk is going to be about type utilities and advanced type utilities. You could also think of it as a talk on advanced TypeScript. If you want to know more about me, you could pretty much Google my name. I've done a lot of things like books and a lot of platforms. I'll let the platforms compete on Google where you will find me. But the one that I'm mostly working on nowadays is a YouTube channel. So that's the logo for that. That's why I put it up there. So my objective with this talk is if you've actually used TypeScript at any point in your life, which will be after 2012 because that's when it came out. If there's any knowledge gaps when you see some advanced TypeScript that people have started to use in their code bases, this should fill up those gaps. So you should be able to understand the weird things that are happening with TypeScript nowadays. Raise your hand if you've done JavaScript development. Perfect. This talk is for you. Raise your hand if you've done TypeScript development. You have found the right room. So it's going to be a lot of demos, and with the demos, I want people to ask questions whenever you have one. So there will be someone who will bring the mic over to you whenever you have a question. Raise your hand. I will open up for like this demo is done. Do you want a question on this particular thing? Does something not make sense to find the gaps that you might have? And I really, based on the audience that we have, I really want everyone to take as much from this talk as possible. This is the last slide. It is. That was a bad joke. OK. So let's talk about the very basics. At its core, we have type annotations. This code that you are seeing right now, and I'll bump it up, is pure JavaScript, except for these things that are type annotations. This is what TypeScript provides. And of course, the objective is that it ensures that X will always be a number. If you don't have it as a number, it's going to give a compile time error. The first concept that I want to talk about with TypeScript is type aliases. So you can take any type annotation that you have, and actually can be even over here, and press command dot. This is VS Code that I'm using. And this gives you the option to extract this into a type alias. So for example, for this type that I was using for this origin that has X and Y, I could give it the name point. And now we have a type point that can be reused for multiple like points, essentially. And you can do that with any type that you are using in a type annotation. So for example, here we have a type annotation for a number primitive, which like you wouldn't want a type alias for this. But type aliases are truly that powerful that you can move it into a name. And then instead of using numbers in your code, you could say num whenever you want to. Please don't do this. Please use number. But that I wanted to demonstrate the power of type aliases before we look at more and more advanced TypeScript concepts. Yes?
How is that different from interface?
So the question is, how is an alias different from an interface? There are a number of differences, but the key one for me is that you cannot use advanced concepts with interfaces that you can with aliases. As an example, if you want to say that this thing is going to be a number or a string, you cannot do this is called a union type, and you cannot do this with an interface. So a lot of the type functions that you will see that I will code, as well as you will find within the standard TypeScript type definitions, would be using type aliases. Another thing that I want to point out is that I'm going to be using GitHub Copilot. So sometimes it might be good, sometimes it might be bad, but that's a journey that you're going to be on with me for this talk. It's also going to demonstrate that even if you are not an expert in TypeScript, it sort of helps you write a lot of the complicated code that you would need to write if you wanted to go really, really deep into TypeScript. Like, what's the syntax for a map type? You could write a comment, create a map type. Bad comment. It's completed that for me, and it's doing something, clearly. And it's not a map type, but hopefully these comments will get better, and we'll get better suggestions for future things. Now, the next thing that I want to talk about is generics. If you've done any form of type programming, other than perhaps Go, which doesn't have generics, you would be familiar with that. Like, most of the developers here are from the Microsoft ecosystem, so .NET kind of things is something that you would have interacted with. Generics were a big deal when they were first introduced to .NET, which was ages ago. Raise your hand if you were there when .NET, I think .NET 2 got generics. Yeah, cool. This is before TypeScript was even a thing. OK, so generics exist to provide consistency contracts between different fields that you might have. As an example, here I have a simple queue data structure, where you can push items into a queue and then you can pop them out. So this is a first in, first out simple collection. It's basically just an abstraction over the JavaScript array. So this is, I've created a data array, and then I'm pushing stuff into it, and then on a pop, I'm using the JavaScript shift method, which basically removes the first element from the array and takes it out. But right now, it's not strict in the sense of you can push whatever you want into it, and you can pop whatever you want from it. So when I get, for example, a result from this queue that I've pushed some stuff into, as you can see, GitHub Copilot was quite, it really wants me to autocomplete something over here. Anyways, but the output that we're getting from this pop operation, we don't know if it's going to be a number or a string, because you're actually allowed to push whatever you want and allowed to pop whatever you want. So it would be good if you could specify that I only accept numbers, and when you pop something from it, it is only going to be a number. And that's why generics exist within TypeScript. So the way you do that is that you add a generic parameter to whatever thing you want to enforce the contract on. Here I'm enforcing a contract on a class. You could also do it, for example, on a function, where you would want the inputs of the function and outputs to have a certain contract that they match. But here, this class has a generic argument, and this is going to enforce that data is going to be of this type, the items that you are going to push are going to be of this type, and for the pop, it's actually automatically going to figure that out, because data is now typed to type T. So pop knows that, hey, what you're going to get from data.shift is going to be of that type T as well. So with that, if I was, for example, to say that, hey, this is only a queue of numbers, we only are allowed to add numbers in here, and these turn into errors. Any questions about generics? Cool. Let's jump into the next one. Generics can be used with aliases as well, and that's sort of where a lot of the power of the types as types that we will talk about a bit more in a bit comes from. You can use generic arguments in types, and then these type aliases are essentially functions. For example, I can create a type for what a queue for a number would look like by saying that, hey, create me a queue type of type number. And now I've essentially created a new type that has item as type number, and the pop method is returning a number as well. Any questions about type aliases or type aliases and generics? Excellent. Perfect. Let's jump to the next thing. We sort of looked at this already. We've looked at generic type functions, and we've seen this generic type function that we've created that can take anything and give back what a structure for like a queue for a number would look like. Let's take it a step back and talk about the basics of type functions. Like if, for example, if you have identity type, let's see if it can complete that for me. It did complete that for me, although I would actually like to write it like this. Now the syntaxes are the same, but this is what we're going with. We take the generic argument as a part of the type, and then we, in the definition of the type, just like we've done over here, we use T to define the structure of what we want. Actually, I don't want a function over here. I just want the type T to be output. So right now, what I've done is I've created a generic function. Generic type function is what I'm calling it. You could also call it generic type utility. And this is going to take a type T, and it's going to give back an identity type T, which means that if, for example, I were to define like number, you could define it like this, right? That's what we did before. You can actually invoke this identity function as well and give it number, and this would be the same. This is going through the identity type function to give me back exactly what it says. So this is an identity type, so that's why it's whatever you pass in is what you get out. So for number, you'd get it something else. Oops. If I were to do, for example, str and pass in string, then the type of str would be, anybody want to take a guess? String, yes. Cool. So that's your first type function that you've ever written. And why this is useful will become more and more obvious as we do more and more demos. Any questions about this? Cool. Let's jump into the next one. So intersection type. So now, what's the use of these type functions? Let's talk about another feature of TypeScript called intersection types. Here I have a type representing a person message, which has a kind and an n once, and followed by a first name, year of birth, and then a car message. And these are, as you can tell, excellent, abstract, really real-world examples. that's sarcasm. But the thing that I want to point out over here is that there is a common structure between these two message types. There's a kind and there's an n-once. So wouldn't it be great if you could define them once and reuse that knowledge between these two messages? And that's where the intersection types come in with TypeScript. So I can actually create a type message over here, which is going to be the same things that is common between the two. And then I can say that the person message is going to be, instead of having this duplicated, is going to be a message and is also going to contain these things. So now person message is essentially something that's going to have what it had before, which was kind and n-once, followed by the other fields. And then we could do the same thing for this as well. Cool? Any questions about intersection types? Perfect. So yes, so the question is, could we use an interface instead of a type alias for this? No, so that's exactly one of the advantages of using a type alias. You can use intersection types. Now interfaces do provide a similar feature called extends, implements, which would achieve the same thing, but of course you wouldn't be able to do that with unions. You could replace intersections with interface extensions, but not unions. But let's just stick with type aliases. As you'll see, there are more and more features that are offered by type aliases that don't exist within interfaces. So that's good. We've created reuse using TypeScript intersection types, but we're not seeing any type function over here. Now, you're actually sort of leaving the thought of, hey, you're going to use an intersection type on a particular type, and that's going to give you the properties of a message. What if you could instead give your fellow developers a function that they could use on a type, and that would automatically add the properties of message to that type? And that's quite easy to do. We could actually say that message is something that is now going to take a type argument, and it's going to return that type and also add to it these things. So instead of now having to remember that, hey, I need to do an intersection for this particular thing, you could say that, hey, create me a message that contains also a first name and year of birth. And this is exactly the same. This is going to be having those fields as well as the fields that you define within the message. So you're sort of starting to see the power of using type utilities and type functions instead of that. So this is just a simple intersection. I wouldn't do this. I would just use an intersection most likely. But you will probably have other fields over here as well that you might want to use to make it worthwhile for it to be a type function. Yes, excellent. Yes, the question is, what will happen if there is a kind also present within the person message? And in that particular case, it will be most likely a union of, sorry, this is also a string. Let's just make it Boolean. Why not? So it'll most likely be like a Boolean or a string would have satisfied this particular constraint. Oh, sorry, yes, that was my fault. Yep. So it would not, that is actually an error because, oh, sorry. So there's this type within never. What's happening over here is if something can never be true, then TypeScript actually gives it the type never. So it's actually, for this particular case, it's realized that it can never be true that a kind can be a string or a Boolean. The other alternative that I was mentioning, that it could have figured out that it could be a union, but in this particular case, it said that there's no overlap between string and Boolean, and therefore it must be a never. This is never going to happen. Something that could have, like, will resolve, I think, is if I have a specific string over here. For example, let's just call it north, and then there's something common between the literal north as well as string. And in this particular case, I think it will resolve to what is the common thing between those two, which is north. We will look at this specific example of using what is this thing that I've used over here called a literal in a bit as well. And then we will look at these unions that result in never as well in a bit. All right, let's jump into the next one. There's a concept within TypeScript called lookup types. Here I have some code that I used ages ago, about 7 years ago at Australia Post. We were doing what is known as, if you've ever driven a, hopefully, probably none of us, not after we became software developers, a Uber, then you would have actually had to go through this thing called known as commercial passenger vehicle accreditation. You might have seen that sticker on the Ubers that you hire. And for that, we basically collected a bunch of information, and this is sort of simplified version of that kind of information. Now, we also collected payment when you were doing this application, and those that are familiar with payment systems, you normally tokenize the credit card into something. I've put in junk over here. But there's a contract over here between the payload that we want the user to send and what this function should collect and return. So we want this to be strongly typed, as an example, to have like a credit card token, basically this thing over here. It should have this exact type over here. But copy pasting is not a good idea. So what would you do? You could, of course, move this into a type alias. Type payment request is equal to that thing. But then you don't have access to this common library. This common library that we're seeing over here is actually existing within an NPM package that we installed that the backend team was maintaining. So would it be possible to get that type from this type that they've created without asking them, hey, can you break down your types into, give them more name, create more type noise? So that's why lookup types exist. We can actually say that, hey, payment request is going to be from the type submit request. And you can see that GitHub Copilot sort of figured this out for us. From the submit request, get me the payment field. So if I were to, for example, type over here as well, it will actually autocomplete all the fields that exist within this as well. So these are the members that exist within that particular type. And I want the payment request over here. So this is exactly going to be whatever is written over here. So if the backend team decides to call it tokens, this will now, from now on, have tokens in it. And then if I were using the payment request return annotation over here, then this would start complaining that, hey, you're not returning tokens, you're returning token, other than the typo. Any question about lookup types? Cool. Let's jump into the next demo. So this is a literal union. So we've not talked about literals before, but I sort of gave a demo of that. Here I'm declaring a type direction called just the literal north. Raise your hand if you've heard of literal types. Cool, some people have. This is like, instead of having a string, you're just saying that only this particular string is allowed. So if I, for example, assign it north, that's perfectly fine. But if I assign like a typo of the string north, that's not fine. So only the literal string north is allowed with this particular literal type. Now I can turn it into a union as well. For example, I can say it can be either the string north or it can be the string south. And then the only things that are allowed are north or south. Anything else is going to be an error. Cool. And it sort of finds the closest match as well, TypeScript, and it's like saying that, hey, did you misspell north? That's something that they added. I quite like that. Any questions about literal types and literal unions? Cool. Let's jump into the next thing. Here we have a type called person that takes a name of type string and an age of type number. We have two people, Jack and Jill, that went up the hill. And then we have this function called log_get. And this is designed to take a person, which can be, of course, Jack or Jill or any other person that has those properties, and then return the value by lookup using JavaScript lookup for that key. So for example, if I were to pass in Jack and age to it, this particular expression would return Jack 20, so it would return 20. But it also does a log in addition to that. This is just some form of, you could, for example, use it to add default values. You could use it for logging purposes, which is in the name. But the restriction over here is that you want the key to be the same as the keys that are offered by Jack. So the person properties only accepts name and age. So you can explicitly list them over here. But then, of course, it becomes a bit weird. For example, if this gets place and it's a string, then you have to, of course, add that over here. And it creates this dependency, and you'd rather be able to figure out what the keys are for a person without having to explicitly list them every single time. So that's why the TypeScript Keyof operator comes in. So here I'm saying that the key is going to be whatever the keys exist within the person type. So right now it exists name and age, and you can see that the key is actually going to be the same. If, for example, if I were to make a typo over here, it's going to complain that the ages is not a key that exists within person. We can combine it with another feature that we saw previously called a generic. So this log_get is right now person specific. What if I could just take a type T And then I could say that, hey, this person, whatever input you have, let's just call it input, of type T, then the key must be the keys within type T. So a few features in there, but the key thing for this particular thing is that you have the Keyof operator to get the key names as a literal union, which is why we covered literals, which is why we covered literal unions, to get the keys for a particular type. Of course, this will turn into an error. Any questions for this particular thing, the Keyof operator? Cool, excellent. Let's jump into the next thing. Go ahead. Yes, so the question is, why is doing a typo over here turn into an error? That's because when we pass in Jill, so it's figured out that, hey, Jill is of type person, so this must be keys that exist within person. That's the constraint that we put over here. Cool. Let's jump to the next one, which is generic constraint. You want to create this function that adds a full name property to any object that provides a first name and a last name property. So for example, if I try to do that right now, even though it's a generic function, and I want to add the full name property to it, it's going to complain. It's going to say that, hey, I don't know if object is going to contain first name or not. I don't know if object is going to contain last name or not. It does in these particular cases that I'm calling it over here. But as far as the function is concerned, it is not constrained by anything. There is no constraint on it. You want to be able to specify, in order to read properties from a generic, to specify that, hey, these properties will always exist. And the way to do that within TypeScript is to use extends for the generic argument followed by what it must contain. So for in our case, it must contain first name string and it must contain a last name string. Cool. And now if, of course, we don't provide it, it's complaining over here instead of in there. And within that, it knows that because this type T is constrained to have these members on it, that first name is going to be of type string and last name is going to be of type string. So that's generic constraints. Any questions about that? Go ahead. Yes, excellent. Could you put this in a type? Yes. So let's talk about why we're going to start talking about, we've been looking at JavaScript and TypeScript in parallel. And I'm going to try and move into just type level thinking and not worrying about the JavaScript, because the advantages you get from that is you can think of types as proofs. So over here, we have mangled in this constraint as well as this the JavaScript code into a single function. What you could do is you could say export type, add full name, and specify that add full name is going to be something that takes a type T, which of course is going to follow this constraint. And then it is going to return to you something which is going to contain T as well as the full name property. So this is just thinking about the type without having to think about what the JavaScript implementation for this would look like. And then you could use this as the proof for this particular function. So you could say that I'm going to have a function called full name, add full name, which is going to conform to this add full name type. Sorry, so the type is add full name is going to be something which is going to be generic, which is going to return unexpected. This is, yes, of course, takes an object of type T, and then it's going to return this thing which is going to have T as well as full name. And then now this proof is actually being enforced on this. And if I forget, for example, to add a full name property, because of that type that we reasoned about in isolation, this thing no longer is the proof for that. So this is sort of writing a unit test. You've written a unit test for what this function must do by just using TypeScript. It's also going to, of course, enforce that you always provide something that has a last name. That's, again, being enforced by this type annotation. Cool. There's one more operator that I want to discuss called the Typeof operator. We have two types over here. We have two variables over here. There's no type annotation right now. We have origin and unit. And we want to enforce that the structure for these two will always be the same. Of course, you could do that by creating that point type that we created. But if you don't want to, you can actually create a link between two variables as well. of course, for that, you'd first need the type of the variable. So how do you go from JavaScript into TypeScript? You can do that with the typeof operator. I can say the type of, for example, origin. I've created a new type called origin, and this is going to be whatever is inferred for this JavaScript variable. So for this JavaScript variable, we know that this is what's inferred when you hover over it, and that's exactly what the type is going to be for origin. So that's the TypeScript typeof operator. And of course, if you don't want to create a type and you just want to create a link between two, you could do this over here as well. Just like I can always take this and move this into a type alias, you can always take something that you have on the right-hand side of a type alias and use that on a type annotation. Cool. Any questions about the typeof operator? OK, so we talked about these types being used as proof, which is a reason why we start thinking about types on their own without being mangled with the JavaScript implementation. Another reason why we want to do that is because the advanced types that we are looking at, they're often used with JavaScript code that is quite hard to reason about. Here I have an object wrapper, which takes an object that, like this type is very well defined. It's going to take an object as its argument. And then whenever you ask for it, it's going to create a shallow clone so that you're not allowed to mutate it. You could call this an immutable object wrapper, a shallow immutable object wrapper for those that are considered that want to think that at that level. But yeah, so we're always going to create a copy, so you cannot mutate the original object. When you try to get a property, we are going to look it up for you. We're not going to just give you the object that you can look it up from it. And you can see some of the things that we talked about, like you can see the Keyof operator over here as well. And then we have a array wrapper. This is again JavaScript implementation, where you take an array, and when you ask for an array, we create a shallow clone for it and return that for you. If you want a particular index, we return from that array that particular index. So you can see sort of there's a difference between like the methods, right? Object has getObj, array has getArray, object has getProperty, array has getIndex. And then we have this wrap function, and this is common for like libraries that you might be using. If you use JavaScript proxies, you might be using library like this. If you use MobX, that might be doing something like this. If you're using Valtio, that might be doing something like this. If you've looked at, there are other libraries that we look at as well that sort of do this wrapping of existing things and sort of give you modified versions of those things. But TypeScript cannot infer this. This function is doing something very weird. It's creating a dummy object with a null prototype, and then it's going through the keys of the object that you pass in. It's checking if it's an array. If it is, it's going to put the result for that key into an array wrapper. Otherwise, it's going to put that in an object wrapper. And like TypeScript loses context about what the hell pretty much at the start of as soon as you create a result, it's like you're creating an object, and you're not telling me what's going to exist within this object. So it's an any, and since you return that result, that's what's coming out of it. So it would be great if when you used functions like this wrap function, the wrapped result would not be any. So you would get type safety, for example, over here if you try to access a property that doesn't exist on this particular person, which has a name. So names is not a property that exists on this thing. It would be great if you could figure out that items is of type array. Like right now, getIndex is any. And we will look at advanced types that will actually sort of make that possible for us. In that journey, the first type that I want to talk about is conditional types. Any questions about why we're starting to think about types in isolation? I knew that there were not going to be questions. I needed a water break. OK. Let's talk about conditional types. I'm going against my advice and looking back at a JavaScript implementation of a function. And this function is designed to take anything, and it's designed to return, if it is going to be a null, it's going to return the literal string null. If it's not going to be a null, it's going to return the literal string not null. So we can see this code, and we know that if you pass in a null, this for null will actually be just this string. But as far as TypeScript is concerned, it's not figured that out. This is an example of, again, inference failing at a very simple level. And this is where conditional types come in. You can actually think about what the type nature of this function is and say that, hey, it's going to be type for this type name thing is going to be something that takes a type T. And then if T is something that conforms to null, and you can see that like GitHub Copilot automatically completed this for us. So this is just me trying to say that even though these things might be hard to write, you have support out there to write these kind of things for you. OK, so we want to say that, hey, if this is something that is going to extend a null, this this type is actually going to resolve to the literal type null. If otherwise, it's going to resolve to the literal type not null. And then we can use this type name result as the return type annotation. And of course, we don't have a generic right now, so we have to make the function generic. And then we have to tie this generic to the object that is being passed in. And you can see an error happening over here. That's because TypeScript didn't understand before, and it still doesn't understand what magic is happening in this simple conditional block. So you have to use what is known as a type assertion to say, trust me. OK, not trusting just, trust me. I know better. This result is going to conform to what I'm saying is going to conform to, which is going to be the type name result for the input type T. OK, so for type name, for null now, it's going to actually infer, hey, it's going to be the literal null. Previously, it was saying it could be null or not null. And for anything else, it's actually going to infer correctly that it's not null. This is a fine example of if a tree falls in a forest, does it make a sound? Well, it does if you look inside of it, but if you're not there, it doesn't. So for the outside world, this function is safe. Cool? Question? Yep, so the question is, what is the difference between unknown and any? The simplest difference is that you cannot use an unknown without saying what it is first, without checking for what it is. So let me create a simple example, export const example, which is unknown. Cool, I'll make it let. You can assign anything to it, like hello. If I can type it properly, my hands are cold, excuse me, like a number or a string or whatever. But if you try to read it, for example, within a function, you have a value unknown, and you try to say that like value dot to string even, like anything, it's going to complain that, hey, value is unknown. You can put anything you want in it, but I won't let you read it because as far as I'm concerned, it's unknown. So it's a safer version of any. With this, you actually have to put an explicit check. If it is a string, then you're allowed to read this value. So without this check, it's going to be unknown. But with this check, this unknown is going to narrow down to what you checked, which is it is a string. Let's jump into the next demo, infer. So we've looked at conditional types. So conditional types can be, like we're starting to think about types as functions. There are lots of things that we do within JavaScript functions. You can sort of do those things within type functions as well. And one of those is you want to be able to create a variable. How do you do that within a type function? Here's an example why you would want to create a variable within a type function. For example, we have isArray type function, which checks if T is going to be of type some form of an array. And if it is, it's going to return the literal array. Otherwise, it's going to be saying that, hey, it's some other thing. And this works fine. You give it an array of strings. It's going to say, hey, it's an array. You give it a number. It's going to say, hey, it's other. It's not a string. It's not an array. But what if we want to be able to figure out what the types exist within that array? You would need to create a variable within this conditional type to identify what the type is for that array and then store it into a new type that you can use in other portions of this type function. So for right now, for an array, it is returning in any. For anything else, it's returning T. So if you pass it a string, it's going to say, hey, this is a string. But if you pass it an array of anything, it's right now saying that it's any because that's what we have over here. And for a number array, again, of course, it's going to be this any. So you want to be able to figure out, hey, when you identify TypeScript that it's an array of something, can you just store what type is into something? And that's where the infer keyword comes in. So you want to say that, hey, it's perhaps not the best named or type operator, but what you want to say is that put this into a variable. So put this into a new type. Infer that and put this into a type. Let's just create a new type member. And then you can use that type anywhere in the remaining body of your type function. For example, in our particular case, we want that to be, hey, if it's an array of anything, store that in a member and return that type as a result. So for a string array now, it will actually return member, which is string. And for a number array, it's going to return the member, which is going to be inferred for number array type. number. Any questions on the infer keyword? So you can see that there's no JavaScript in this. We're really thinking about types as type code. Let's go to the next thing, which is mapped types. So if you have conditions, you have if conditions, you have functions. What other programming languages features that we use? We have loops. Can we do loops? And that's where mapped type comes in, array.map. This is a version of that. It is type map, mapped types. Okay, so we have a type point, and we want to create some form of a type that once assigned, you cannot modify it. We can do this with another TypeScript feature called read-only. So I could, for example, create another type over here and call it read-only point. And then for each of these, I could assign read-only to this. And then if I, instead of saying it's a point, it's a read-only point, that because I have added an annotation that this member is going to be read-only, once it's been created, you're not allowed to modify it. So you'll see an error over here, cannot assign to X because it is read-only. But wouldn't it be great if you could generate this type, like have a cake and eat it too? Like have this point type, but be able to generate a read-only version of the point type without having to explicit all the members again and again. And that's where one of the features of map types. Let's first create a basic copy of this. Let's see if Copilot can figure out what, nope. It's asking me to list the members again and again. Instead of doing that, let's use a map to figure out what the members are going to be. So we want to say that for each of the keys, we saw the Keyof operator, that exist within point, put them into, let's just call it key in Keyof point. This is I'm in type9 here, I'm not writing JavaScript here, but the for in is something that you might have used within JavaScript. This is map sort of using the same syntax. So it's saying, hey, create a key called key from the keys that exist within Keyof point. What are the things that exist within this? We know it's the literal union of X, Y, and Z. And then for each of these, map them out to be the looked up result for that key from point. So we've looked at lookup types. So this is actually going to be a loop. This is going to say first, hey, key is going to be the literal X, and then it's going to say from point, look up the literal X. We know that that's going to be, of course, number. Same for Y and same for Z. So this is actually just a copy of that. So you can see we passed in X, Y, Z of number. We're getting back on the output result X, Y, Z of type number. But of course, that's not what we wanted to do. We wanted to be able to modify these when they go through the map as well. And we can do that with map type modifiers, and one of those is read-only. So this is saying that take all of those properties, and while you're mapping them, add this nature of read-only to them. And so now this is actually a read-only point that we were looking for. And as soon as you add, remove a member, that's going to go away automatically from the read-only point. And once it passes through, you can see that on the other side, they're coming out as read-only. So go ahead. Yes, so the question is, can you conditionally make some of them read-only? The answer is yes, and you would use conditional types for that. I'm not going to try and code that right now. But yes, so you can combine the features that we've been talking about to do advanced things like that. Let's jump into, so we've looked at one map type modifier, read-only. What other map type modifiers exist? So here's some type that I've created. Again, a real-world example. This is not a real-world example. Where members are read-only, they are optional as well and non-optional members as well. So those are the kind of two natures that exist within properties. They are either read-only or not read-only. They are optional or not optional. So when we are mapping this to the output, we can actually, for example, we've seen that we can mark them as read-only. And now example result is going to have all of those members as read-only. There is also a minus read-only, which is actually going to remove the read-only nature from any of the members. So we have a read-only name in the input, but in the output, it's no longer going to be read-only because read-only is going to get removed. Now, if you're going to add a plus operator, people are going to say you should have a plus. So minus operator, people are going to say you have a plus operator as well. This is exactly the same as that, but hey, it exists to make people happy. And then similarly, there's the other side of this that we talked about, which is optional. So we have a question mark over here. So you could say that, hey, make them all as optional as well. Let's just look at them in isolation. So all of the properties on the output are now going to be optional. And you can see that they've all got that question mark, the Riddler. And you can also put minus question mark, because you could remove optionality, and now put phone was optional in the input, but it is not in the output. Cool. Of course, if you're going to have a minus, you're going to have a plus as well, which is the same thing as not having it, but that's supported. Any questions about map type modifiers? Okay. Now we're really going into the deep end. Let's talk about the never type that came up before as well. So there is a special circumstance that happens within code that means that it can never happen. For example, this particular function can never return. So if the only annotation that you could have over here is never. This is the TypeScript's problem to this, because it wants to encode what's happening in your JavaScript code into types. So this is the solution that TypeScript team has. This is never. And interestingly, you can assign a never to anything. So for example, you can assign it to a string, because as far as TypeScript knows, it's never going to return. So this thing is never going to be anything other than a string. In fact, it's never going to be anything. But if you want to say it's going to be a string, I'll let you do that. And this is actually useful, right? Because this function is not yet implemented right now. You don't want the rest of your code to start throwing errors like looking red. It's up to you to say that, hey, this is in progress. This is coming soon. So it allows you to assign never to anything, which means that it's actually a part of any type. So when I say that it's going to be a string, you could actually say it's going to be either a string or a never. And this TypeScript will actually be smart enough to know that if you're doing a union with never, it's essentially the same as not having that union. So in the inferred result for verbose, it's actually figured out that it's just going to be a string. And that means that if you'll see this quite commonly in a lot of the map types, and a lot of the conditional types, this use of never to essentially remove types from the type system. Here I have a generic function, generic type utility function, that takes a type T and then sees, hey, if it's going to be a null, infer the result to be the type null. Otherwise, infer it to be the type never. And when you pass in, for example, multiple into this thing, for example, you say pass in the type null or string, it's going to loop through all of them. So even though conditional types aren't loops, when you pass in a union, you're using them as a loop. So it's going to do condition, 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 union, union, union. So it's going to say that, hey, null comes in, null comes out, string comes in, never comes out. So the result is actually going to be null or never. And we know that anything or never is the same as the base type. So this is actually going to be just nulls. So we've just created a type function that only gives us null from any given input type. Any questions? I am scared. Because if you're thinking at this level, then you've got really complicated code. OK, let's talk about the built-in. Yes, go ahead. The question is, what's the difference between never and void? Yes, the question is, what is the difference between never and void? Void is this function does return, but it doesn't return a value. Never is this function never returns. Cool. Let's jump into the next thing. So we've looked at read-only type. There's actually, this type is actually built into TypeScript. So we didn't actually need to create this. There's this mapped type utility exists within TypeScript. That's why the talk is called type utilities. So you just use that, and that's exactly, as you can see, the structure is exactly what we wrote and hand code and understand ourselves now. There is another one called, we looked at read-only. Read-only exists, but there's no actually opposite of read-only. So you'd have to pretty much, if you want a mutable version, you'd have to do this. You'd have to do this, create a new type over here, call it mutable, F2, mutable, the capital M, and then basically remove read-only. And this will actually take a read-only point if there was one and turn it into a non-read-only point. But other types exist for the other map type modifiers that we saw, like partial is an example. So we want to make all of the things optional. Why does this use case exist in the real world? Well, here's an update to do. You want to take a to-do, and you want to take a fields to update, but you don't want the user to be able to provide have to provide all the fields. For example, you just want to be able to say, hey, update the to-do and just change the done property to true. And this is like quite common with like Redux style code, with set state within React. You want to pass in a portion of the object members that you want to change. So what would be a great type annotation over here? We know we could create a map types with putting a question mark on everything. But this exists within TypeScript. This is a type utility that TypeScript provides. And you can see that the structure for partial is the same as what we saw. It basically adds a question mark to all of the things. And with this, of course, now this is going to be fine. Don't have to, and you get a nice autocomplete over here. It's going to tell you what are the partial members that you could mutate if you wanted to. Any questions on the partial type utility? Cool. Let's jump to, there's require as well, which is, so you take an optional config, but you make sure internally in your private config that all those members are present. You give them default values using the null coalescing. This is JavaScript, question mark, null coalescing. To make sure that, hey, if color is not provided, it's going to be green. If radius is not provided, it's going to be 0. You could do this in other ways as well. You could take them as arguments. You should probably take them as arguments. But when you have this fact that you are always going to provide them with members, how do you ensure that when you try to read them, like you want to read color, you know that it's not going to be optional because you've modified the config to always have these members. Wouldn't it be great if you could specify that this particular config that you're going to take is always going to have all of these members from an optional type? And that's where required comes in. That's the opposite of partial. We are saying that this is always going to be present. So this is going to take that circle config, then has optional members, and then you can see in the structure it's minus question mark. Remove the optionality from the members. You could have written this yourself as well, but you don't need to. It's built into TypeScript. It's called required. Let's look at the next one, which is pick. Okay. So we have a point 3D that has members x and y and z. This is like reverse inheritance. You want to remove the member z from this. You only want to get the member x and y from this. You could, of course, write that type yourself, but wouldn't it be great if you could just use type magic to figure that out? And that's where this comes in. So this is the correct answer, I think. Yes, pick. This is Copilot doing its job. It's saying that, hey, take from, how would you implement something like this? I'll do just the mental thought experiment. You could say that, hey, give me all of the keys from x, y, and from point 3D, which I'm taking as a generic, and then only, in fact, of just those keys, actually just only loop through these keys that I'm going to take as a second argument. And for these keys only, in the result, give me whatever was in point 3D. And that's what pick is going to be. So you can see sort of over here, it's saying that only loop through properties in K. So normally we would do properties in whatever is the first type T. We are saying, no, take another type for the keys and loop only through that, and then map them to the output. And there's also a generic constraint over here. It's saying that the keys that I'm going to accept as a second argument, they must be the ones that exist within the first type. So the only things that exist in this particular type that I'm passing in point 3D is x, y, z. So if I were to, for example, pass in h over here, it's going to be an error. That's the pick type built in. Again, you could write this yourself now, but you don't need to. It's built into the type system. Let's talk about exclude. Okay. Any questions about pick? Sorry, I forgot to ask. Cool. Let's talk about exclude. Now, the opposite of pick would be like omit. You want to just remove z, right? But that's a bit hard. Before we talk about that, I want to talk about another thing called exclude. Exclude works with union. So there are actually two types, and if you look at the type definition, the TypeScript docs, it actually says exclude takes a type T union. It's designed to work with unions, and more specifically, perhaps even unions of just literals. We have all the keys from point 3D, and all is going to be the literal x, y, and z. That's what the Keyof operator is going to do. And we want to only get x and y and not z. So we want to exclude the key z from the literal that exists, the literal types that exist within all. And that's why this type exists. So exclude from all just the member z. Now how does it do it? It uses that never trick that we talked about. It's saying that, hey, take a type T, and then if it is also present in U, then just remove it to never. So it's going to go, hey, x, so for all x is going to come in, x is going to go, does x exist within z? Nope, it's never. Sorry, if it doesn't exist, it's going to go into the else block, which is actually t. So x is actually going to come in and it's going to go to t. Y is going to come in and it's going to go to t. So y is going to be mapped to my y. But when z is going to come in, it's going to be like, hey, z is extending z, so therefore it's going to be mapped to never. So therefore z is going to get deleted in the output, and we will only get x and y. So this is the exclude type. As you can see, like, it is programming, but it's programming within syntax, and it's so hard to come up with a programming language that has these features built into the type system, and they've done it over like 10 years or something to realize that lookup types was added like 7 years ago, and conditional types maybe 3 years ago. It's like, hey, we have lookup types. We could use them for mapping the output, and that's map types kind of things. But yeah, so this is that. And now that we have this, we could actually write the thing that we were looking for. We could write this. We wrote this with a pick, right? This make a point 2D by removing z, but we're actually just picking x and y. What we could do is we could say, hey, pick everything except z from the Keyof that exists in point 3D, but exclude the member z from it. And this would be fine. This is going to give us x and y. This is removing z. But of course, you don't need to do this because this is what omit does already. So let me actually comment this out so you can sort of see that you could write this yourself, but you don't need to, because you could say, hey, omit from point 3D the member z. And if you look at the type definition for omit, it's going to be what I sort of wrote, which is, yeah, so pick from T, but exclude the things that exist also within the other thing kind of thing, this weird thing that we wrote. But you don't need to write this. Omit is your friend. But you understand how this works now. Any questions about this? Okay, so we have 9 more minutes. Let's talk about non-nullable. Honestly, this is going to be a weird one. So we have string or null or undefined. We have, yeah, that's literally what's on the other side of this. And we could definitely exclude null or undefined. So that's the objective with non-nullable. You want to remove things that are nullable. Honestly, I wish they called it non-nullish. Nullish, like nullish coalescing is an operator. Nullish is a term that JavaScript has formalized. It means null or undefined. So non-nullable, nullable is essentially nullish within JavaScript. They really roll off the tongue, don't they? I'm just seeing people getting, but yeah, so non-nullable, remove null or undefined. We can write this. We can take an input type. We can remove null and undefined from this. And this would, for this thing that has string or null or undefined, we only get string. But the type definition for non-nullable is a bit different. You saw that for a second. I'm going to hide it again. But the way it works is an interesting dive into TypeScript itself as well. We have a union here of things that have foo of type number and bar of type number. And we can, of course, intersect a union. But when you intersect a union with something else, what you're actually going to get is another loop. So you're going to get foo of type number that also has baz of type number, and then bar of type number that also has baz of type number. So this is going to actually expand into all the things that might combine with this union with this single type. So of course, there's 2 in the union and 1 over here. So it's going to be 2 types, 2 into 1. So you can see that over here, that like, here's an example of this union intersection. You have foo and baz. If you, for example, miss something, it's going to add it over here. So that's how the AND operator, the intersection, works when you intersect with the union. Now there's something encoded into the TypeScript's brain that when you intersect with certain types, it does certain things. What you saw over there with the string and a literal was actually an example of that as well. It's encoded that when you do a string and a literal, it's going to resolve to the literal because that's the thing that's common between them, rather than the expansion, like combine the properties intersection version that we've been looking at. So for a null union with an object, this is actually encoded in TypeScript's main as the base type of all things that are not null and undefined. So for a null with an object, it actually returns never. This is encoded in TypeScript's main that, hey, if you AND with an object a null, I'm going to give you never. If you AND with an object an undefined, I'm going to give you a never. And therefore, if you AND with an object a null or undefined, what's going to happen? It's going to be null or object, sorry, null and object, followed by or null and object. The first null and object is going to resolve to never. So never or undefined and object, never. So it's never or never. So never. So that's the output. And if you have, for example, a value that is going to be nice over here as well, it's going to be never or never or string, because string and object is actually, again, encoded within TypeScript main to give you string, because it's the object is the base type for this. And that's what we get. And that's actually what the definition is for non-nullable. It actually takes the type T, and if you pass in a union, it's going to do the loop, of course, and intersects it with object. This has some interesting artifacts. That this is actually a better definition than what I wrote, but that will get very weird. So just use the non-nullable built-in type is the lesson I can give you. Okay, let's look at one more type. Return type. So you want to create a dependency between two things. For example, create user, and you don't get too lazy. You're like, I hate TypeScript. I don't want to use type annotations. Isn't there a way I could infer this? Hey, like when I hover over this, I can see its ID and name. Do I have to really write it? You don't. You need to first get the type of create user. We know how to do that. So take a variable and infer its type. So type of create user. This will be what the type is for this function. We can hover it as well. It's going to be a function that takes a name string and returns these things. But what you want to create for the type user is this return type, right? So there's actually a type utility within TypeScript for this called return type that does this thing. Takes a type that is of a function and returns its inferred return type. How does it work? I sort of gave that away. Infers it. So return type is a type utility that enforces that you must pass it a function. Cool, that's what this is doing. I don't care how many arguments this function takes. It must be a function that returns something. And now if it returns something, whatever it infers, or like whatever it returns, infer that result and return that result. Otherwise, this is going to be ruled out by the generic constraint anyways. You'll never be able to pass in, so I'm just going to put in any. That like programmers have bad days as well. But this case is never going to happen. For a function that extends this, it's like that default case. We've all seen that default throw exceptions. I don't know what happened wrong. This any is that default case. But yeah, so if it extends a function, infer its result and return that, and that's how we magically get the return type of a function using this return type utility function, generic function. I just like adding things to things. I do not. It's killing time. There's another use case for this. If you've done React programming, components often provide hooks that are designed to use the component, and these hooks are designed to be the props for the component. For example, this use counter is going to return and count an increment, and that's going to be the props for the counter component. You could do, of course, return type. Let's see if GitHub, yes, it's sort of done it. But you're also learning GitHub Copilot, by the way. That was a side point, even though I don't get paid for it. I'm not a Microsoft employee. It does the camel casing. It does linguistic analysis, so it actually doesn't understand the difference between this and this. So it'll actually quite commonly write the wrong case. But yeah, so return type for type of use counter will give us the count and the increment. Raise your hand if you've used GitHub Copilot. That's an interesting one. Ah, cool. Nice. A few people have. Do you normally leave it on or do you leave it off? Haven't decided. Cool. That's where I'm as well. Sometimes I'm like, just stop. Just stop. It's that one person. It's like Google. It's like, did you mean to search for? No, I did not. Which is why I don't do Google searches on stage. Okay, we could create this like mapped type ourselves as well for this wrapped thing that we saw, and this will actually sort of combine. Let's see type wrapped result of type T is going to, yeah, see, that's exactly what I wanted. Let me break this down. Not break my laptop, break down this type. So this is like for an object, for all the keys. If it's an object, put it in an object wrapper. Otherwise, if the thing is an array, put it in an array wrapper. That's the block that we have over here. And I've tried to create this wrap result for this. And what I'm saying over here is I don't actually need the inferred result of you. Yes, I do actually. For all of the keys in input type T, this is me writing the same code that I've written in JavaScript, but explaining that to TypeScript, doing that in TypeScript's mind what's supposed to happen. So for all of the keys in input type T, if it is an array, this array.isArray condition, then infer what is in that array, and then create a wrapper for that member. We've looked at this unwrapped array before, so create an array wrapper for that. Otherwise, if it's an object, just create a wrapper around the whole object. That's what's being done over here. And what we're saying over here, yes, is the wrapped result, and that's the end of it.
You're running over.
Yes, perfect. And I think that's it. Export. Sorry, what's missing? It's missing end bracket. Oh, yes, you're correct. Perfect. See? It all made sense. Thank you very much for coming. You can find me by Googling my name. I also have a YouTube channel. That's where I'm wasting most of my time nowadays. Enjoy NDC.